Jai Hind all of you. I am Manish Kumar, Assistant Professor in Department of Computer Science and Engineering at Kumar Engineering College. So, today my third complex topic is on searching and sorting. Right? So, firstly, I just tell you ki what we are going to do whenever we are going to search a particular element in a given list, we are going to implement any of the searching algorithm. Okay. So, we have two types of searching. Search means we are going to find some key. So, firstly, I will tell you about linear search, that is called as sequential searching. Secondly is binary search. Okay, binary search. And in sorting, it is categorized into two types: internal sorting and external sorting. Internal and external. Okay, internal means when the number of elements that we are going to sort are sorted in RAM, in internal memory. So the name comes internal sorting. And when secondary storage comes into picture, means we have a large number of elements and we need to store those elements in a external storage, that is secondary storage, that is hard disk. So then a name comes external sorting. Okay, so in internal sorting I am going to discuss about bubble sort, selection sort, bubble, selection, insertion sort, insertion, then comes the quick sort, okay, then merge sort, then radical sort. Okay, so in today's lecture I am brief you about all these types of sorting as well as these two types of searching. Okay, so let me start with linear search. So this is the algorithm in front of you. That is what we are going to search. We are going to search an element in an array. So first parameter is an array. Okay. Then we will give the size of an array and the element which we are going to search. Search element. That we call it a key. So these are the three parameters that we pass. So these are the steps that I have written. Actually, firstly I just set the pointer, the position to -1 because the searching will take place in an array, and we know that in an array the 0 index position is there, right? So I will set a variable I is equal to 1. That first loop will start from the first element, and what we have to do, we just keep on comparing each position element, and when that element is found at particular position, we will print that whether it is present or not. The same process has been done here. So the loop will start from I less than or equal to n. Okay? If at any particular position a of I, that key is found, then I will set the position is equal to 1. This position is a type of a flag. It is type of a flag, type of a signal. If the element is found, then the value has been updated is equal to 1 and we will print that value. Otherwise in that variable -1 is there, and -1 reflect that element is not present in our search. Okay, because we know that the searching can be take place in two ways, firstly the list is unsorted, okay. Secondly, the list is sorted. So there is little bit difference between them. Unsorted means the elements are randomly distributed. Sorted means we know that the elements are already sorted in ascending order or descending order. So searching is a little bit easier. So in case of sorted, what we will do, we just check out these index positions, whether the element exists in between this array or not. This is the only difference between sorted and unsorted. In case of unsorted, we just start the loop from the first position and we keep on checking until the nth element will be found. Okay? Now, so we will print the position. Again, we will go to step number 6 and exit. Otherwise, increment will be done in the list, and then we will check is the second element that we are going to search, is the third element that we are going to search, and so on. Okay? If position is equal to -1, if position is equal to -1 remains -1, then we will print the value is not present in the array. So this is a simple algorithm, linear search, that is also called as sequential search. Okay, students. So this is the program in C. For your brief, firstly I just write the main function. I have declared the variables. I will ask for the size of the list, enter the elements in an array, then I will input the value which I want to search. Okay, then loop will execute. Yes, from here this searching will take place. For loop will start 0 to I plus plus. Okay, then we will check, comparison will take place here. If we find the element is found, then we will print the element is found at location I. Otherwise when we exit from the loop, when exit take place, when we are keep on incrementing and we reach to another position. So I have put here the condition, if I is equal to n, then it will print the element is not found. Okay, this is a simple program of linear search. Okay, now comes the binary search. So what happened in case of binary search? In case of array, obviously we will just give the element, list of elements that is in an array A. In an array, we have a lower bound, that is the maximum size that we called upper bound, and which element we have to search, that is the key. So here we will pass 4 parameters, right? So what happened in this, the simple logic is that, just understand, this is an array, given an array. Okay, what I have said, we will just, this is the beginning, and this is the end. Okay, the first condition is that in binary search, the condition is that key elements are in sorted order. This is the condition, sorted order. Elements must be in sorted order for this search to be implemented. Elements be in sorted order. Okay, so firstly I will just check whether the array exists or not. What is the condition of existing an array? This beginning must be less than end. Then I will understand that this array will exist. So what happened? Each and every time I will find out the value of middle element. How I am going to find it? Middle is equal to beginning plus end divided by 2. Right? For example, 0, 1, 2 up to 9. 10 elements are there. So how I am going to find the middle element? 0 plus 9 divided by 2. It means it comes out to be 4.5, that is 4th index position is the middle element. Then what happened? I will check the element which I am going to search is that element which exists on this mid index position. I will check. If the element is less than mid, then I will search the element in the left partition. If the element which I am going to search is greater than this middle element, then I will search the element in the right partition, and so on. And this loop will go on recursively. Okay. So the same procedure is illustrated in this algorithm. Step 1, we will set the beginning. Beginning is set to lower bound. Okay. End is set to upper bound, and the same position variable is set to -1. Okay. If the element is found, then I will set the value is equal to 1. Otherwise, it will remain -1. -1 indicating that the element is not found in our list. Okay. Then we will start a loop, for loop. So what happened here in step 3? Repeat step 3 and 4 while beginning is less than end. Less than end matlab array exists. Until unless array exists, we just keep on finding the middle value. Just I have illustrated here. So mid is equal to beginning plus end divided by 2. If the element which we are going to search is exist at middle element, then it's okay. Otherwise, what we will do? We will search element either in left partition or in right partition. So what happened when the element which we want to search exists in left, then what we will do? Here we already have a lower bound, then we will update the value of upper bound here, which is updated like u is equal to mid -1. Right? If we are going to search in the right partition, then here the upper bound is set. We need to reset the value of lower bound, which is equal to mid +1. That is done in this algorithm. See, position is equal to mid. We will print position. If not, if element is not found in middle position, then what we will do? Go to step number 6. What step number 6 says? Exit. Element found and go to step number 6. If not found, then what we will do? Else if we will check whether the A mid, that element is greater than that value. Then what we will do? We will set the end position. We will set the end position. Upper bound is set. Otherwise, if the element exists in right partition, then we will set the beginning. Here I have set the mid. Lower is equal to m +1. है ना? If position is equal to -1, then we will print the element is not present in the array. Right? So in this way, we just implement the binary search. So this is the program of binary search. same I have illustrated. I have initialized the variable, declared the variable firstly, low, high, middle, and then ask the input number of elements, enter the elements, then find the element which we are going to find, then initializing low is equal to 0, that is a 0 index position, high is equal to n minus 1, that is the maximum element, last element in an array, then I will find the middle element, low plus high divided by 2. So the loop will execute while low is less than or equal to high. I will check whether the element which I am going to find is less than middle element or greater than middle element, right? Then in the same fashion, I will check and print the value is found or not. Okay. So this is a program for binary search. Now sorting. Yes. So what is sorting? Sorting is just a technique for rearranging the elements in either fashion. Which fashion? Either of the one fashion, ascending or descending order. Okay, which can be, the list can be given in numerical or in alphabetical or any user defined order. Okay. So there are two types of sorting. I have told you that internal sorting means when the elements exist in RAM, that is internal memory. So it is called as internal sorting. External means when secondary storage comes into play, picture. Secondary storage. Okay, for the bigger elements. So there are two types of sorting. So first sorting, so I will discuss about insertion sort, insertion, bubble sort. These sortings we have to discuss. Bubble sort, selection sort, right? Quick sort, merge sort, and radix sort. So let me start briefing this sorting one by one. Okay, number one, first is insertion sort. So as the name suggests, insert, we are going to insert something. So I just explained you with the help of simple example. Let us assume we are given with a deck of cards. Okay. So I have put all the cards on the table upside down, right? And one card is in my hand. Okay. Now what happened? So for this sorting, I just pick the first card which is on the table, put the second card. I will compare the second card with the card which is in my hand. So I will insert this card. If the card that I have picked is less than, then I will insert it before, otherwise I will insert it after that card that is in my hand. So now I have two cards in my hand. Okay. Now I just pick the third card. I will compare this third card with these two cards. If the element that I have picked, the card that I have picked is less than, I will insert before, otherwise afterwards or in between. Now I have three cards. Now I will pick another card, third card from the table. I will compare this card and I will put accordingly. So this is how insertion sort takes place. So the same process has been explained. So one card is already in my hand. Then I will start loop from the second card. So this is the reason I have started. Repeat step 2 to 5 for I is equal to 1 to n. Now temporary. Then the first element has been put in a temporary variable, because now that card I have picked from the table, I will compare that card which is in my hand. So that card which I have picked, I put it in a temporary variable. I will compare it. Okay. No matter how many cards are in my hand, so I will compare with each and every card, and that element that I have picked, that card that I have picked, that will go at its original position. So this is how insertion sort works. So this is the index variable j is equal to I minus 1. We will repeat until unless this temporary variable is less than is equal to aj plus 1, j minus 1, set aj plus 1 is equal to temp and exit. This is how sorting takes place. So let me illustrate with the help of a simple example. So for example, this is the card that was in my hand. Okay. Now the element which I have to compare means in my hand means I have this variable 30 in temporary. Now what happened? This is the first card. Now I have to start the loop, this from second position 20. Now there are two elements. I will compare 20. Okay. Is 30 is less than 20? No. Then what we'll do? The list will be like this, 20 and 30. Right? Now the variable, now the card that I have picked is now 10. Now 10 will be compared with both these. Okay. Now after comparing, I will check, and I have found that 10 is less than both elements. That 10 will be inserted before 20 and 30. Right? Now three elements are there in my hand. Now it comes the 40. 40 will be compared. Okay. 40 will be compared. with 10, 20 and 30. So it is greater than, then it will be inserted after these elements 20, 30 and 40. Okay, now comes the 50. The 50 will be compared with 10, 20, 30, 40 and it will be inserted after these elements 50. Okay, now let us assume now I have to insert 5. Say one more element is there, 5. So what happened? This 5 will be compared, okay, with all these elements and this 5 is less than 10. So what happens? So in that array, what happens? All those elements, 5 will be inserted here, then 10, 20, 30, 40, 50, they will all shift towards right. In this fashion, the insertion algorithm will take place. Okay, just keep in mind the example of the cards that I have explained. In the same fashion, this insertion will take place. The element which I have picked from the table will reach at its original position while comparing all the elements that exist in an array. Exist in an array means exist in my hand. So I have picked the card, compare and insert. Okay. Now this is insertion sort. This is the C program. This is the main function. And this is the procedure that I have listed here. See, I have used the while loop for comparing the element with the elements that exist in the array. Okay. So the shifting will take place here. Okay. Should I move? Right. Now, selection sort. So this is also one of the easiest sorting technique that exists for sorting. What happens? Selection. Selection means I am going to select an element. So firstly, I just explain you with an example. So this is a list to select. So I have just select this 0th position element. This is the 0th position element that I have selected. So what happened? 0th position element. So what happened? This 0th position element will get compared with all the elements that remain in a list. Okay. So what I have done? Selection sort. Selection means I have selected this 0th position element. Right. So 65 will compared with 70. So I will compare, is 65 less than 70? Then no change needs. So 65 will keep and 70. Now, firstly I have compared it with 670. Then I will compare it with 75. Is 65 less than 75? Yes. No change will take place. Then 65 will compare with 80. 65 is less than 80? Yes. No change required. Then 65 compared with 50. 65 is less than 50? No. If this case exists, then we will interchange the elements, swap the elements. 50 will come here, 70, 75, 80, 65. Okay, students? 60, 55 remaining elements will remain the same. Now, at 0th position, 50 will come. Okay, now 50 will compare with next element, that is 60. 50 is less than 60, no change will take place. Then 50 will compare with 0th position will compare with next element 55, less than, no change. 85, 50 is less than 85, no change. Then 50 will compare with 45, yes. Again, no. 50 is less than 45, no. Then we will interchange, that is, we are going to swap the elements. Now the list will be 45 will come here, then 70, then 75, then 80, 65, 60, 55, 85 and 50 will come here. So this is the completion of first iteration. So in case of selection sort, what we have seen कि after the completion of first iteration, the smallest element will reach its original position. Right? So 45 reached its original position. Now next time second iteration will take place in the remaining list. Again in this list 70 will be the 0th position element, it will compare with remaining all the elements. After the completion of second element, I will get the second largest element, then third largest element, then fourth largest element, so on. Right? So what you have to keep in mind, in selection sort, we will select the 0th position element. 0th position element will compare with all the remaining elements. If we will get smallest element while comparing with the 0th position element, then we will interchange it. Otherwise, we will keep on proceeding. Okay. So after nth iteration, we will get the sorted list. Okay. Second thing we have to keep in mind, after the completion of first iteration, we will get the smallest element at its original position. So this is how selection sort will works. So this is the algorithm. Okay, and this algorithm I have find out the smallest element. So for this smallest element, this is a small procedure that I have written here. Start small a. This is the same that for finding the smallest element from the given list. Okay, and this is the program of selection sort in C. Same procedure will be called here. This is how the same procedure that I have explained has been represented with the help of a C program. Okay, students. Now comes the bubble sort. This is again one of the important and easiest shortening technique. Now, what happened in this bubble sort? Bubble means we just consist the pair of two elements. In Hindi, we will call bubble means bulbula, है ना? So that bubble will fly downwards to upwards. ठीक है? So in the same fashion, we will make a bubble of two elements and we will compare them. So while comparing, 33 will be compared with 44. ठीक है? तो 33 is less than 44. No problem. Then again, bubble will proceed upwards. 44 will compared with 44 is less than 22. No. Then what happened? We will swap the elements. Swap or interchange. Then list will become 33, 22, 44, 11, 66, 55. Then bubble will proceed upwards. 44 and 11. We will again compare. 44 is less than 11. No. Then again list will change. They will swap with each other. 11, 44, 66, 55. This is the third. Okay. Then again this 44 and 66, no change will take place. 44 less than 66, it's okay. List will remain same. Then 66 will compared with 55. No. Then we need to change 33, 22, 11, 44, 11, 44, 55, 66. Okay. So this is the completion of first iteration. So in this bubble sort, after the completion of first iteration, the largest element will goes at its original position. This is the case of bubble sort. Okay. This is after the completion of first iteration. Then again second iteration will take place for these elements, and the same we will use the same procedure. We will keep on comparing pair of two elements and proceed till last. Okay. So after the completion of another iteration, we will get every time we will get the largest element, then second largest, then third largest, and so on. Okay. This is bubble sort. Okay. This is the algorithm that I have shown here. Okay. We keep on comparing. Two for loops will be executed here. This is first step 4, then J2 and -1. Okay, students. So this is I and this is J. Okay. So this is the C program. This is the C program. So here I have make a bubble sort procedure. Okay. Two parameters are passed. This is the same procedure that I have shown you. Two for loops are there and comparison is take place. 2 pair is going on and we will use the swapping code here. This is how swapping take place. Okay. Now next the quick sort. This is one of the very important algorithm, very important program, quick sort, and it is one of the efficient shorten technique. Number one, it is very efficient as compared to bubble sort, selection sort and insertion sort. Number two, it uses the concept of recursion. It is based on, third is it is based on divide and conquer approach. So there are so many factors which make this algorithm important. Divide and conquer approach. Number 4, it is also called as partition exchange algorithm. It is also called as partition exchange algorithm. So there are a number of factors, okay, which make this algorithm very important. So let me illustrate with the help of example directly so that you can understand what are the steps which we have followed. So this is the algorithm of quick sort, right? Quick sort, again, sorting in array, we will set the lower limit, we will set the higher limit, that is lower bound and higher bound. If the array exists, then we will call another algorithm that is called partition, right? Then how it is possible? Let me show you with an example. So in this case, in this quick sort algorithm, we will see the first element, check it, and we will mark it as a pivot element. Number one, first point, we will mark it as a pivot element. Then two variables are declared. Let it be P and Q. P is set in front and Q is set at last. Okay. So we will compare this P with 50 and finding it whether this P is greater than that pivot element. This is the first check that I have to find out. Number one. Secondly, I will find out the element which is in Q is less than that pivot element. Okay, let me check. 30 is greater than 50? No. Then again, P will point here. 10 is less than 50? No. Then again, 90 is less than 90 is greater than 50? Yes. So Q will keep on incrementing and reach here. And P will reach at 90 and Q will be checked for smallest value. I will check. Is 70 less than 50? No. Then I will decrement it. 40 is less than 50? Yes. So Q will reach here. Then if such condition exists, then we will exchange these elements and the list will be updated like this. 50, 30, 10, 40 will come here. Okay. 80, 20, 90 will come here and then 70. And same procedure will be started again. P and Q. Now P pointing to the next element, Q pointing to the next element. Again we will check. Is P greater than 50? Yes. It will be set here. Is 20 less than 50? Yes. Then again we will interchange these elements. Okay. 50, 30, 10, 40, 20 will come here, 80 will come here, 90, 20. Okay. Now 20 will point here. Q will point here and P will point here. Right. Now, if the situation comes when these variables P and Q interchange each other, then what we will do? Then we will exchange the current variable with this pivot element. Okay. Now, what is the current variable? This variable Q is the current variable because P we have set first. Secondly, we have set Q. And this is the position where interchange take place. So now this Q will exchange with pivot element and the list is divided into two parts. So I have divided the list here 20, 30, 10, 40, 50 lies in between and 80, 90 and 20. This is the right partition. So this is the partition how it take place. It means that when this interchange will take place between P and Q variable, this pivot element will go there and it will partition the list into two parts. Then 50 will reach at its original position. All the elements that lies left are the smallest element, which lies right are the largest element. So this is how we can check whether partition has been done correctly or not. Then again this quickshot algorithm will take place for these two partitions. Okay, this is how quickshot works. So here again this quickshot algorithm, low, mid -1 left partition, mid +1 and high, this is the right partition. Okay, this is the right partition. Okay, this is the procedure that I have explained for P and Q variable. We will check every time pivot element, the current element is checked with the pivot element for the largest and smallest value, and swapping will take place. Okay, so this is the C program that I have listed here. This is the partition algorithm. Okay, the quickshot algorithm. This is the quickshot algorithm. Same quickshot, and every time we are partitioning mid and partition procedure is called, that is brief here. Okay. Now last is the Radix short. Radix short is the shortened technique which exists on digits, particular digits of a number. Okay. For example, I just explain with the help of a small example. This is a too big example. So let us say I have 102, 500, 705, 506. Let us assume 506. Now 500, 500. ठीक है ना, and 100. So I need to short. So what happened? I know that these digits, this number is divided into number of digits. ठीक है? This is the zeroth, this is the tens, and this is the hundreds place digit. So firstly, in this, we will start shorting on the basis of zeroth digit. ठीक है? Now short it. So which number comes? 500, 100, then comes 102, then comes 705, then comes 506. Then we will short on the basis of tens place. 500 remains there, same, 100 remains there, 102, 705, because at all the tens place 0 is there, so no change will take place. Then again we will start shorting on the basis of 100 place, ठीक है, which is the smallest element, 100, then 102, then comes the 500, then comes the 506, then comes the 705. So this is the shorter list. So this is how radix sort works, digit by digit. So this is the algorithm that I have shown you, number of digits in large. Okay, and this is the radix sort algorithm that I have briefed here. Okay, students. So I hope this you will I have just briefed the idea of all the searching and shortening techniques in this lecture. So hopefully you will understand these shortening techniques. Okay, students. Thank you.